Hello everyone. Welcome to my channel BBTechHub. So today I'm going to start switch. You know, I think that a switch is a layer 2 device. Layer 2 means data link layer. And the previous session I have discussed about the hub, which was the layer 1 device. And we have seen what are the demerits of a hub. We cannot say the demerits because when hub came in the market, it was a fruitful device while configuring the LAN. Maybe there are some features need to modify, and that is why the next device came in the market was actually bridge. And after the CCNA syllabus, and here you can see 1.1.b, here it is mentioned to discuss about the layer 2 and layer 3 switch. So before going to layer 2 and layer 3, I will try my best to clear all this concept. That is, what is switch, what is the features of the switch, benefits of switch, types of switches, that is types of switching, who are the manufacturer, number of ports present on a switch, function of switch, like that. So now I am starting actually what is switch. Switch is a layer 2 device. Layer 2 means data link layer. By default, we call it as a layer 2 device. And what is the job role of this device? Switch is responsible for transferring the frames from one host to another host within the same network. That means we can say switch is a LAN device. In a LAN, under the same network, whatever may be the host want to communicate with each other at that time, the switch is the device. Switch provides the connectivity so that devices can get the chance to transfer the frames from one device to another device. So now the thing is that when this switch is going to transfer the frames from one device to another device, and this process we call as switching. This switch has several features. The first thing you can see, this is a layer 2 device. Always remember. Second, switch is a full duplex device. In this diagram, you can see if A is transmitting the frame to B, then of course at the same time A also can receive the data from B. And the thing is that ever you see what happens if it is 100 Mbps switch. So if A is transferring the data at the speed of 100 Mbps and there is a separate path for receiving the data, there is also device A can receive the data with the speed of 100 Mbps. So have you observed? That means it has an 100% efficiency. If it is the half, the efficiency is 50% because it is using a shared media. But if you go for the switch, there is two different path over there. One path is device is transmitting the data and another path the device is receiving the data. That means there is no chance of collision. Is it clear? This is the reason you can understand what happens if we use the switch in a network. The performance of the network improves because there is no chance of collision. Am I clear? Now the thing is that you can see it is a full duplex. That what I said. The sending and receiving may happen simultaneously. Fine. Now why we call it as Unicast? Because it believes in point-to-point communication, 1:1 data transfer. Fine. Now this switch maintains a table and we call that as called as the MAC table. Is it clear? In this MAC table, what happens? The ports are mentioned over there and what are the MAC addresses corresponding to that ports, that is also mentioned over there. So whenever a switch is going to forward a frame from one host to another host, it goes to the MAC table and verifies the destination MAC is connected to which port, and that after that detection switch forwards the frame to that intended port. Okay. Now, the switch has single broadcast domain and multiple collision domain. This is a very big concept we have to understand. The first thing we have to understand, what is my broadcast domain and what is my collision domain. So for here, I'll give a brief discussion over here. First, we have to understand what is collision. So always remember, when there is a shared media like hub, a network segment is there where multiple devices are connected. So it is a which media? It is a shared media. In this media, if one device transmits data at a time, then only data transmission is successful and there is no collision. But you think two devices at the same time transferring the data, then of course both will get collided. Is it clear? The moment there is a collision between the data packets, the whole communication of the network will be stopped, and this is nothing but a situation called as collision. So what we call collision? Collision is a situation where frames sent by one NIC get collided with the frame sent by the another is NIC over a common media. Is it clear? That situation is called the collision. Now, what is collision domain? What is domain? So we know domain is nothing but the logical boundary of several entities. So here, if group of network interface cards are involved in a communication where if any collision happens, all the network card gets affected, that means communication is stopped, then that whole combined NIC cards forms a collision domain. So collision domain is nothing but the collection of several NICs where frames sent by one NICs get collided with the frame sent by another NIC, and all the devices will get affected within that domain. Is it clear? Now the question is that the second important term in this networking, we have to understand what is broadcast and what is broadcast domain. These two are very important, my dear. Broadcast is also a situation where frames sent by one network interface card is received by all other network interface card in a LAN segment. Is it clear? So what is broadcast domain? That means collection of NICs which forming a logical grouping, and when one frame is sent by one NIC is received by every NIC within that domain, then it is forming a broadcast domain. Am I clear? So always remember, please keep it in your mind. A hub is a single collision domain and single broadcast domain. But luckily, our switch has multiple collision domains. Am I clear? But single broadcast domain. Switch has multiple collision domain and single broadcast domain. But the hub has single collision domain and single broadcast domain. So you can observe one thing. The broadcast issue is also in switch. Okay. Now I'm coming to this thing. So that the thing just I told you. Now here is the question. The next thing I would like to discuss. What is the benefit of switches? A switch has multiple ports so that we can connect multiple devices in a LAN. That is the first benefit. Of course, it is a full duplex device. So as an aggregation, we get the 200% of the efficiency. If you think it like that, because if I say transmitting is the fullest and receiving is also fullest. So if I go for as an aggregation, it is about 200%. Switch is an unicast device. Switch, there is no collision issue. Switch has removes this collision issue. because collision issue exists with hub, but with switch there is no collision issue, and it reduces the broadcast issues. So now we will discuss one by one. Okay. Now the question is that what is switching? In a technological term, switching means the function of the switch. So what is the function? Main function. Switch primary job is to forwarding the frame from one host to another host. But remember, within the same network. The moment bridge switch came in picture. So today's video, I will discuss about the switch in brief, not in detail, because when we'll go for the switching part of CCNA, at that moment we'll cover the whole thing. Now this thing, you know, this switch or this network device is coming under 1.1, that is the switching are three types. That is store and forward, cut through and fragment free. So when we will discuss about the switching, in the switching part of Cisco, at that moment we'll discuss it in details. Okay, so far you should remember there are three types of switching, that is store and forward, cut through and fragment free, and this is the default Cisco switching. That means whatever the switch Cisco is giving to the market, that switches follows this type of switching, that is called fragment free. Now next part we will see the switch which has several ports for connecting the devices in LAN. So what are the number of ports available in the switches? If I go for the fixed switches, so this is 24 to 48 ports. We consider for the fixed switches maximum 48 ports are available. If you go for the industrial switches, that is up to 52 ports are possible. If you go for the modular chassis switches, so the port density is very high and you can get 100 of ports in a single chassis. Is it clear? Can you imagine 100 of ports? There are several companies are manufacturing the switch, just like Cisco, Arista, Juniper, Aruba, Dell, Extreme. All these companies are manufacturing the switches. There are several switch manufacturers are in the market. Is it like Cisco, Arista, Juniper, Aruba, Dell, Extreme, like that? Apart from that, there is another manufacturers are there. So you can see these are the manufacturer like Netgear, D-Link, Microtech, like that, Allied Telsis, like that. Okay. And you can get more manufacturer. Actually, what happened that I'm telling you, there are different application areas. So in the applications areas are different, so of course the devices will be also different categories. Same switch, maybe their features will be different. So as per the requirement of the switches, so there are several types of manufacturing companies are in the market. Okay. Now here is a question, why switch is a broadcast device? We know it is doing the communication in unicast. Then why again we are calling it as a broadcast? So you think a situation over here, just I want to demonstrate over a situation. Suppose four devices are communicating with each other. Fine. Suppose this is A, this is B, this is C, and this is D. And all are connected with a switch. Fine. You can see all are connected with a device switch. And you can see this is the ports of the switch. This is maybe F0 by 1, F0 by 2, F0 by 3, and this is F0 by 4. And when these devices are connected with the switch. Every device has a network interface cut, and of course it has a MAC address. Suppose I'm assuming this MAC is AA, this is MAC is BB, its MAC is CC, its MAC is DD. Now take a situation, just you have powered on the switch. Switch is maintaining the MAC table, and at the very beginning the MAC table is totally empty. Am I clear, everyone? The MAC table is empty because just first time I have powered on the switch, that is empty. Now a situation has come, A is going to send a frame to B. So nothing but it is sending a frame. Yes or no? It is sending a frame. So in the frame, the first 6 byte is the destination MAC, then is the source MAC, and then data and CRC. So here, if A is sending, that means A is source, B is the destination. So what is the MAC of A? That is AA. So in the source MAC, it will put AA, and in the destination MAC, it will put BP. Now see, A is sending this frame to switch, and switch is receiving this frame through F01 port, F0 by 1. So what will happen? In the F0 by 1 port, switch is receiving a frame whose source MAC address is AA. Switch can sense through the F0 by 1, a frame is coming. So of course it can sense the source port. Of course in the source port it will get the source MAC, and what is the source MAC? The source MAC is the AA. And immediately switch will enter this AA entry to the MAC table. Now switch will see what is the destination MAC. The destination MAC is B. Now switch will go to the MAC table. Switch is a device, man. Switch is not a human being, that it has a manipulation capability. Then what the switch will do? Switch will look for the MAC table, and there is a no entry for BB. So what switch will do? Switch will send a broadcast frame and asking, hello, anyone is BB in this network? Understood? So what the switch will do? Switch will flooding the frame. The switch will broadcast it. Now every device will receive this frame. So when switch is flooding this frame and it is reached to every device, then who will respond? B will respond, because B resembles, I am BB. So B will now send an acknowledgement to AA. Switch will send a thank you message to A, that A, I have received the frame. So you see what will happen, the game will change. Now the who will be source? B will be the source. So in the frame, whose MAC address will be over there? B's MAC address. And now who is the destination? A, because B is sending an acknowledgement to the A. Now this frame, what will happen? B will send to switch. Switch will receive this frame at F0 by 2. Immediately switch go to the MAC table and it will enter the entry, that is B. What switch is saying? Hello, in my F0 by 2 port, I have received a frame BB. Now it will go to the destination. Switch has to forward frame to the destination. So destination is AA. Already AA is mentioned over here. Now switch will go for the Unicast. So in that way, switch will go for the broadcasting until it is fulfilling the MAC table with all connected host addresses. Am I clear, everyone? Understood? How many devices has powered on or connected to the switch until fulfilling the MAC table of all connected, active connected devices? Switch will go for broadcast. The moment the MAC table is there, switch has a response of every query. Switch will start what? Unicast. Is it clear, everyone? So when switch is doing the broadcast, this is a very good question. So switch broadcasts the frames until the MAC table is fulfilled with the MAC address of all connected active devices. The moment MAC table is fulfilled, switch will go for the Unicast. Have you understood? So dear, one thing, this is a very big issue, this broadcast. Later on you can understand. So in a switch, this is the only one problem that is a very big problem, that is the broadcasting, which may compromise the performance of a switch in a network. But this broadcast issue cannot be, always remember, removed, but it can be reduced. So be careful. The broadcast issue cannot be removed, but can be reduced by a technology that is called the VLAN, virtual LAN. Virtual LAN is a technology, later on we will discuss in details, which reduce the broadcast issue, but sorry, cannot remove it. Okay. Now the thing is that what is the benefit of using switch is another benefit, that is removes collision issue. Yes, there is a no collision in the switch. Why? Actually, you see, one switch is the one LAN segment, and every port of a switch is one micro segment. Am I clear? One port of a switch is connecting one device, creates one micro segment. One micro segment is a collision domain, and every collision domain can handle the collision issue independently. It will never affect the other collision domain. Am I clear? And this every small port, we call it as a micro segment. So switch has removes this collision issue by using a technology that is called as micro segmentation. Micro segmentation isolate the collision domain. And remember one thing that I told previously also, a switch, if it is a 4-port switch, it has 4 ports collision domain. Am I clear? So there is a no collision issue of a switch. If a port is down, only this port is down, other ports will not get affected. Am I clear? So can you imagine how vital switch is? Now what is the function of a switch? There are 3 main functions of a switch, that is MAC address learning, frame filtering and forwarding, and loop avoidance. Okay, later on we will discuss what are the types of switches in the market. There are 2 types of switches, believe. One is non-manageable, another is the manageable. What is the difference, my dear, that is manageable and non-manageable? Non-manageable, no operating system is present. Manageable, operating system is present. If operating system is present, that is, we can configure the switch as per the requirement of the network. Am I clear? An IT admin can configure a network by using a manageable switch. Then what is the need of non-manageable switch? Non-manageable switches are very cheap and it can use as a connection point for connecting the different devices. Understood? This manageable switches are also further categorized in 2 different. One is layer 2 and layer 3. If it is a layer 2, means in the data link layer, so layer 2 switch is working in nothing but my data link layer, and your layer 3 is working in the data link layer and the network layer. Layer 2 switch uses MAC address. Layer 3 switches MAC address plus IP address. Layer 2 switch transfer frames. So layer 3 switch uses frames plus packets. Am I clear? Layer 2 switch believes in switching, but layer 3 switch believes in switching plus routing. So you understood. So that means a layer 3 switch has a capability of working as a switch as well as a router. But a layer 2 switch can only work as a switch. Is it clear? You are getting my point? So Cisco 2900 series is a very important layer 2 switch. Is it clear? It's a series, layer 2 switch series, that is 2900. So we are using 2960 also. And if you go for the layer 3, so you can say 3500, 4500, 6500, these all are the layer 3 switches. So everyone, you have got a brief idea about the switch. So switch is a versatile device. Okay, a person can say for a long time about the switch. So whatever the information today I gave you, this is the basic information. Again and again, I'm repeating. The moment we'll go for the switching, we'll go in depth of every topic. So far, thank you everyone.